Today in 9.7, we're going to work on factoring special cases of quadratics. So really what this means is we are still going to deal with the ax squared plus bx plus c. But we're going to look for times where there are special cases. So where we have exact opposite numbers that cancel each other out, or we may have exact duplicate numbers where there's a doubling effect, but we're going to look at kind of several cases here. So let's look at our first examples. Now, first of all, on some of these examples that are up here, you can clearly see that this one doesn't have a value in front of it. So we just have to deal with the cases, kind of like we were doing before. So if I were to look at this, it'd be a plus plus, which is case 1. It would be a sum of 8. And remember, if this is a case 1, these are both going to be plus signs. Now, the other thing that I would consider in this one is you only have one number to factor, because there isn't a number greater than 1 here. So if I factor 16, 1 and 16, 2 and 8, and 4 and 4. Now I do want you to remember in our pattern that we talked about, there's going to be kind of this doubling thing that happens sometimes. So I can clearly see that 4 and 4 is going to be what gives me a sum of 8. So that means that this is going to be 4 and 4. Now remember, that means that probably on an answer, if you were to look at a test, you might see something like this. And you kind of have to know that these are the same things. Okay, now in this second one, I do have a number in front of the variable squared, which means that I'm probably going to have to factor something more than once. And also look at this to kind of see if there's a greatest common factor. There isn't in this one, but if there is one, that usually makes your work a lot easier to do. So if I start out with this, I'm going to go over on the side and kind of deal with my cases. So it is a minus plus, which means it is case 2. Which means that's going to be my sum. So it's a sum of 12. So if it's case 2, I know down here, both of these are going to be subtraction, because that's what case 1 is. Or excuse me, case 2. Also, I'm going to add my g's in here, but with room in the front to be able to add stuff as I factor it. And then don't forget, as soon as you see something in front of that g squared that's not 1, you know it's got to be an evil clown problem. So you got to add those brackets. I hope you can see the evil clown in there still. And I'm going to go to factor. So I'm going to factor 9, which is 1 and 9 and 3 and 3. Okay, now I'm just going to move this over just a little bit so I have enough room here. And then I also have to factor 4. Now remember, if a number here is other than 1, that means you have to factor both these numbers here. So this will be 1 and 4 and 2 and 2. Now remember how we talked about we like repeating ones. So that means we should probably check out the 3 and 3 and the 2 and 2. So if I check out this pattern, 3 and 2 multiplied together would give me 6. And 3 and 2 here would give me 6. And they want to make sure that these two right here are going to give you a sum of 12, which it does. Oops. So that means that down here, the 3's have to go with the g's, and all of the 3's are hooked to 2's. So it's going to look like this. Now that means that you'll probably see an answer that looks like this. Since the 3g minus 2 is something that gets repeated, they'll write it with that exponent of 2, so you only have to write it once. Okay, let's take a look at one other one. This is kind of an interesting one, really, because there's no middle term. So I want you to think about this. Can you imagine that I could add a 0 in there? Now really it doesn't matter if it's plus or minus, but as long as there's a 0 in there, you might kind of get where I'm talking and follow this pattern, at least at the beginning. After you do a couple of them, you might not need it. So if I go to look at this, if it's a plus and then a minus, it's going to be a case 4, which means that down here, one of these is going to be plus and one of these is going to be minus. And I have just x's in the front because there's no other number here in front of the x squared except for 1. So in a problem like this, I have to factor 64. So 1 and 64, 2 and 32, 3 doesn't go into it, 4 goes into it 16 times, 5 doesn't, 6 doesn't, 7 doesn't, but 8 does. Now remember, on this kind of a problem, we didn't add kind of our difference part in there. Let's do that real quick. This one not only is a case 4, but it has to be a difference of 0 in the middle. Now, at that point, if you want to write plus 0, minus 0, it doesn't matter because 0 is 0. But these two right here are the pair that's going to give me a difference of 0. Now, also remember we talked about that repeating numbers are kind of the big name of the game in this section. So if I were to put these here, the idea with these is that when you do the pairings, the positive 8x and the negative 8x are going to cancel each other out. So you'll have a difference of 0 in the middle. So really what I do is if I see this and I know it's a minus, really what I think of as x squared gets broken up into x and x because I want the same thing times itself. And if I go to 64, I can kind of think about that. That would be 8 times 8. It's the only pairing for 64 where the numbers are identical. And that kind of gives you the information that you need down here to be able to put them in. The only thing you have to remember is one is plus and one is minus. Okay, let's see if we can do maybe one more. Okay, here is our example. So nothing I can factor out and no number in front of m squared. So good things so far. Easiest of the ones we could get. So it is a minus plus, which means that it is case 2. Which means that it has to have a sum of 6, which comes from this term right here. If it is a case 2, both of these have to be subtraction. And then I'm going to go in and I'm going to factor 9. Only one I have to factor since the number up here is 1. So 1 and 9 and 3 and 3. Now remember we talked about using the pairings that are doubling. That's going to get us over here. So this would be 3 and 3, which means that this would be m minus 3 squared. Okay, I think we may be even able to get to one more. Oh, now this is a really good one. It says that the area of the square is 16h squared plus 40h plus 25. Find the length of the sides. Now we also know that if we're doing this, if it's a square, these two sides have to be the same. So when we factor this, we should have two sets of parentheses that are identical. So let's take a look like we were talking about before and start to factor, just like we've been doing. So if it's a plus plus, it's a case 1, which means it's a sum of 40. Right there. Now if it is a case 1, I know that when I go to do these, both of these are going to be h plus. Now notice in front of the h squared, there's a 16, so a number bigger than 1. Anytime you have that number bigger than 1, you had the evil clown. Now in this one, I'm going to have to factor 16, and I'm going to have to factor 25. So 16 is 1 and 16, 2 and 8, and 4 and 4. And for 25, it's 1 and 25, and 5 and 5. Remember how we said we like those pairings that are identical. So let's try 4 and 4 and 5 and 5. So 4 and 4 is 20 when I multiply it together. Also 20 here. And remember, if I want this to work, these two have to give me this sum. So it works. So that means in this one, the 4's go with the h's. No worry about placement because they're both pluses. And then the 5's go here. 4h plus 5 squared. Now, notice what that means. It's saying that this side must be 4h plus 5 long. And this side must be 4h plus 5 long. Now, if you ever get one of these and you're like, man, I'm not sure if that's right, you should be able to use FOIL or the shortcut method and multiply it back out in order to be able to get what you need to have there. Okay, remember we said that we thought these should be identical, and they are. So there's a lot of things that are kind of going in your favor there.